Welcome to springlib.
For this problem on the topic of AC circuits, we are told that for the sample problem provided, the generator's EMF is a maximum, and we want to find the voltage across the generator, the resistance, the capacitance, and the inductance. And by summing these voltages, we want to show that the loop rule is satisfied. Now, we note that we obtain a maximum value when the time t is equal to pi over 2 omega d, which is 1 over 4 times the frequency f, which is 1 over 4 times 60 hertz. And this gives a time of 0.00417 seconds, which is 4.17 milliseconds. And so, therefore, we have that the maximum EMF times the sine of pi over 2 is equal to epsilon m times the sine of 90 degrees, which is 36 volts. Now, for part B, when t is equal to 4.17 milliseconds, then the current I is equal to I sine omega d times t minus phi, which is I sine 90 degrees minus 24.3 degrees, which is 0.164 amperes times the cosine of 24.3 degrees. So this is 0.1495, or to three significance figures, 0.15 amperes. And then Ohm's law gives us the voltage across the resistor VR to be I times R, which is 0.1495 amperes times the resistance of 200 ohms, which is 29.9 volts. For part C, the capacitor voltage phasor is 90 degrees less than that of the current. And so, again, at t is equal to 4.17 milliseconds, we get the voltage across the capacitor Vc to be I times the sine of 90 degrees minus 24.3 degrees minus 90 degrees times the capacitance or the reactance across the capacitor Xc. And so this is I times the reactance Xc times the sine of 24.3 degrees. And so if we substitute our values in, this is 0.164 amperes times reactance 177 ohms times the sine of 24.3 degrees. And so we get the voltage across the capacitor to be 11.9 volts. Now for part D, the inductor voltage phasor is 90 degrees more than that of the current. And so at t is equal to 4.17 milliseconds, we have the voltage across the inductor VL to be I times the sine of 90 degrees minus minus 24.3 degrees plus 90 degrees times the reactance XL. And so this is minus I XL times the sine of 24.3 degrees. Again, if we substitute our values in, this is minus 0.164 amperes times the reactance 86.7 ohms times the sine of 24.3 degrees. And so calculating, we get VL to be minus 5.85 volts. And lastly, to show that the loop rule is satisfied, if we add our results for part B, C, and D, we see that the EMF epsilon is equal to VL plus VC plus VR, and so therefore the loop rule is satisfied.